Welcome to another episode of the ChrisRodMaxShow, where every week we discuss what's new in AI, what are the trends, what's happening, and what it means for anyone who is developing or exposed to these technologies in our enterprise. And today we have a super exciting topic. We are discussing about logical AI. And for this, I have a terrific guest. She's Sophia Kalanovska, CEO of Tromero, and she's here today to explain us and discuss with us what's happening in logical AI these days. Welcome, Sophia. Great to have you here.
Thank you so much for having me. Yeah, great to be here. I'm Sophia, co-founder of Tromero. We do workflow automation, and we use logical AI with generative AI. I'm a PhD student. I used to focus on explainability and trustworthiness of AI. In a way, I still am in the company. In the kind of research I used to do, it was a lot about combining those old school techniques with neural networks. It wasn't large language models per se, but it was, again, those kind of architectures which are not by default interpretable or by default human understandable. I think what my journey looked like to get to this point.
But now it seems to be a comeback, right?
And what they realistically learn is how to predict the next word in a sentence.
If we start using logical systems, robust systems, will we be able to have here more robustness in that?
So the way reasoning AI works is you have chain of thought.
Will that be superseded by logical AI? Now that you mentioned this concept of interpretability and work on neural networks, anyone who is doing any type of applications at enterprises, startups, whatever it is, they often hear, oh, with neural networks, this is like a black box and we do not understand what is happening. So what you were doing was trying to provide some transparency to this, or was it in another direction?
So yeah, the way neural networks work is you don't have to specify what they should find important. So you don't specify the features, they find their own features. And that's really amazing in tasks that we as humans find really difficult to explain, right? So how you see something and how you understand it, how you read and understand and write, and all, like, language, for example, is really difficult, right? Like, it has many complex rules. Actually writing everything out in a way where a computer would be able to replicate it well is nearly impossible. So when neural networks started as a research direction, the whole point of them was, what if we don't tell the AI what to learn? What if it just learns what it needs to learn by itself? So it doesn't only learn the task, but it learns what to focus on in that task. Unfortunately, with that does come a level of uninterpretability. So we don't really know how it learned to make the decisions. And we can talk about that more in reasoning models as well. And like, one might think that kind of explains the chain of thought, but it's still not entirely interpretable, because that's also part of what the neural network is actually trained to do. But I think I'm getting ahead of myself here.
It is something that, of course, there are so many things here to discuss. And you were mentioning just now this idea that languages have rules. And when I think about logical AI, I think this sounds something that is maybe rule related, that there's some structure. So why don't we discuss a little bit of what is it logical AI? So for someone who has never heard of it, and maybe they only hear many terms, there is a GenAI and Spatial AI. What does it make it different? What is it unique about it?
Yeah, so logical AI by itself, I mean, it has many, many strands, but it's anything that is rule-based and it's goal-directed. So you have to be trying to solve for something. So in a way, any kind of more traditional algorithm could be seen as logical AI. So I heard someone say that we call AI everything that software doesn't do. So if you look at like autocorrect, that used to be AI and now it's just part of computers. And like, you had a lot of things that were considered AI and now you just call software. Logical AI is difficult to define because of it. So I would define it as anything that could be expressed purely with logic-based rules and you can solve for it. In the many, many years of computer science, you do have a lot of very clever algorithms that have been used for optimizing problems. you could use in many real world scenarios.
Indeed, when one thinks about rules and these rule-based systems, one realizes, hey, this is nothing new. So way back in the 70s, 80s, it was extremely popular. Even to this day, there is a dedicated community in academia, in research, just focused on rule-based system. However, what is it different now, Sophia? So if we think that this has been around for decades, and somehow it was very popular decades ago, and it lost sort of a bit more relevance. It's not something that we hear every day, but now it seems to be a comeback, right? So you are very excited about it. You're working on it. What has changed?
With the development of generative AI, you actually have a lot of new applications that are being opened up again for logical systems, so symbolic systems. So anything that is based on language, understanding language, or writing language, but also needs to follow really strict rules, or it has to solve things that are computationally inefficient. It should actually rely back on an algorithm. So what we firmly believe at Tromero is that there are amazing applications for generative AI, but generative AI is not the be-all end-all that solves all problems. So they are non-deterministic systems, they lack structure, and they, when faced with combinatorial problems, find it difficult to actually solve them, right? So the way that they express results is, or like the way they like solve a problem is by predicting next token in a sentence. And what that realistically ends up meaning is that they're autoregressive. So a small mistake in the middle of a sentence completely derails the entirety of the solution or the entirety of the answer. This doesn't obviously happen in logic-based systems. So it offers that like kind of level of robustness. And I don't think the logic-based systems by themselves have many applications that haven't yet been explored. I think wherever they were able to be applied, they had been applied already. But I do think that what generative AI gives you is the ability to open up new applications, create more structure around GenAI, and in some cases as well, maybe use the generative AI component as a translator onto those rule-based systems.
Here, there is quite a lot to unpack. It has been so a very insightful response. But however, for someone who is new, let us take like a step back and think, for example, ChatGPT. You were mentioning that language has structure. So someone will say, hey, then ChatGPT must be in some way logical, right? It is taking as an input some sentence and then outputting also some sentence. But you're saying these type of systems, they are not logic because just a small change can derail complete output. However, if we look at the space of tools around ChatGPT and GPT models, we see how there are so many techniques that people are trying in order to constrain responses, in order to have some reliability around. So why is it that GPT-like models and tools such as GPT are not already logical AI? And maybe these techniques, do they help in making them become a logical AI, or are they something completely different?
Yes, techniques like that could be used. Taking a step back to large language models, they are not logical based systems. The way that they learn is they've been given a lot of information. So they've been given the entirety of the internet to learn from. What they realistically learn is how to predict the next word in a sentence. And whenever you predict the next word in a sentence, there's the next word and then the next word, then the fifth word depends on the fourth word, but then the 1,005th word depends on the 1,004th word. And actually, every time, because it's a probabilistic based system as to what word is being produced, the probability of there being a mistake is never zero. So this is why large language models get things wrong. It's why they might hallucinate. And the thing is, at the point that that happens, at the point that like something that is a little bit unlikely gets chosen as a word, the whole like paragraph can get derailed, right? Now, large language models have been trained on a lot of information. They have really developed over the past couple of years, and I would say that they will only get better, right? I most definitely believe that a lot of tasks would be able to be solved with large language models alone without the help of any other external systems. However, I do think that there will always be an element of non-determinism and an element where things may go wrong.
Back in the 70s, back in the 80s, when all these rule-based systems were all the rage, one of the reasons that I see why they start losing relevance, why people start turning in other directions, was this challenge that we needed to specify every possible rule for every possible scenario. So modeling, let's say, like the real world became basically impossible because we cannot really foresee all the possible options. And not only that, but just the amount of rules that one needs to curate, it became very brittle as a system. If we start using now logical AI and combine it with, let's say, GPT-like models, so here you mentioned transformer architecture and so on, are we also exposed to the same challenges that were back then? Or is there a way to have this robustness in terms of the amount of data that we can process and also all the type of use cases that we have without really providing too much insights and context, while at the same time having structure in what we're getting? Is this perfect world possible, or are we exposed to trade-off if we go one route or the other?
It's a good question. So I think that the rules themselves could be defined in a very high level terms. So they don't need to be as precise as they had to be back in the 70s or 80s. And now you can still use the generative AI component to match to those rules and make sure that everything works like you'd expect it to work. I think that we're entering an interesting era of combining the robustness of computer science with the flexibility that large language models provide. And we've never really had software that can do those things together before. So I do think that you could use a rule-based system that works from a high-level perspective, and then use a large language model to be mapping to those rules and make sure that those rules are actually following without specifying every single thing every time.
To spark the imagination of our listeners, what is it that they would be able to achieve with a logical AI system paired with a generative AI, a GPT-like one? Which type of applications or benefit will they be getting if they start combining these techniques?
That's a good question. So it kind of depends what you want to get out of it. We believe that the biggest benefit to it is being either able to extract structure. So we have seen that quite often in Lego applications. So you'll need to be like creating almost like kind of playbooks based on contracts, where you need to include certain things or you don't need to include certain things. Those are kind of rule-based components that companies wouldn't have extracted. They wouldn't actually know what the rules actually are. So they would like to like process thousands of documents and actually get those rules out, and be able to have a more, let's say, templated version, or know what does or doesn't go into a specific contract, depending on the situation. So one application is going from what we've been doing for decades, and finding where the logic lies within it. And then another one is actually having very strict rules that have to be applied in certain situations. So like, let's say you have an HR chatbot, and then you have to make sure that certain things are being followed from a policy. So every time you respond to a query, then you need to check that the logic actually corresponds to whatever logical structure you have imposed. There are other applications where if you have kind of one-to-many or many-to-many matching, so if you are doing kind of like cross-referencing from some, like, for example, depositions, like that's one of the examples that we're looking into. But another example would be you have a lot of invoices, and then you need to be matching them to your zero transactions. And then again, that's quite a difficult matching to do. Using very standard computer science algorithms combined with the generative AI component to actually understand what's going on behind the scenes is the kind of applications we're also talking about. Like, one way to think about it is generative AI is very wide intelligence. It can do a lot of things. When combined with logical AI, it becomes way more narrow. So we are focusing on very specific use cases in different industries where those problems come up.
So let's imagine that I'm a lawyer. And then, for example, we have cases, let's say, mergers and acquisitions, where these contracts can be hundreds of pages long with so many clauses and very detailed provisions and covenants, etc. If I start using a tool that is equipped with logical AI, what can I expect that I'll be getting that until now was impossible?
So one of the things you'll be getting is you'll be able to, for example, tell in particular cases when not to include a clause, what exactly needs to go into a mergers and acquisitions contract. It's almost a high level you've never had over your documents. So that's one side of it. Another thing we're working towards is we use those logic-based systems to highlight points of inconsistencies between generated content and the input documents or input transcripts or input, whatever the input is. And that allows people to go and then look at it. I think that this kind of goes back to how we believe that there is a paradigm shift in how humans interact with software. So up until now, a lot of automation was you let the computer do it, right? Like it's just completely end-to-end done. It's deterministic, it's going to be done well. What the applications we're looking at now are much more fuzzy. They're the ones that software couldn't address so far. And because they're non-deterministic, people want to check them. And then one of the problems is if you are, let's say, writing documents with generative AI, which parts are most likely to hallucination? And like hallucinations are a massive problem and a very, very big topic of discussion in AI. And I don't think that they will be fully solved. But what you could do is find those areas of like high uncertainty and be able to highlight them and get a human to actually check them. So that's not to say that everything was automated or everything needs to be checked, but really a very small portion of things is actually being brought up to the attention of the user of the system.
Now listening to you, something I was thinking it is, for example, when we think about negotiations for commercial agreements between countries, and there are so many considerations that need to happen before the contract gets to be signed, in that one has multiple negotiating parties. And then if we think, for example, about the European Union or the United States, then it has a line with supranational rules and state rules and so on and so forth. And then as a result, this can take years until the contract is finally signed. If we start using logical AI for these type of negotiations, will we be in a situation where we can have maybe faster negotiation, maybe come up with contracts that are more robust in terms of the rules, that it looked at all these 1,000 pages agreements and different documents that are spread out throughout multiple legislations and regulation bodies and so on, and come up with better contracts in general?
I feel like there's a lot of human element here, so I don't know if that will be one of the first applications which is going to get adopted. I certainly like the idea, though. I do think that touching on what you're saying about like multiple rules, legislation, so on, that is something that could be used in logical AI sense as well. So you could write all the trading permissions between countries and the tax you have in different countries and whatever else. And when selling to them, you may need to be applying different rules, right? Like you might have different ways of processing personal information in different countries. So that's also something that you could apply the rule-based systems. I do like your idea with the contract. I think it's a good application. I think that we're probably far from actually adopting it.
And another topic that is also always in high demand in enterprises is scenario planning. So where people want to be able to maybe not necessarily predict, but to get an idea of what will happen with. And in these days, with all this turmoil that's happening across markets, tariffs, changes in some rules and so on, it becomes even more important to forecast or try to get just a perspective on what can happen if something comes in place, if there is a new tariff and this is increased or decreased and so on and so forth. With the logical system, will we be able to have this type of scenario planning? Will it be possible to create these systems that help us explore different alternatives?
Yeah, absolutely. So planning is a very big area of AI, which is partly logic based, depending on like which kind of strain of research you look into. But what's the way that those systems work is a lot like what I would say the industry now calls agents. So you have a goal-directed system, and then you have an initial state, and then you have a goal state, a place where you want to be, and then you have a set of actions, and then you'll be exploring those actions until you get to your go state. So whenever you're planning different scenarios and you're creating maybe even multi-agent systems, you could actually see like different variations of what might happen. Now, I think that everything that is kind of simulation based has some drawbacks, like simulations are non-perfect, but it is most definitely one of the areas where I would say, yeah, planning is used in.
Now you're mentioning agents. It's a very popular topic, and someone who has maybe doing agents for a bit longer, they'll say, hey, in fact, this is highly connected or related to reinforcement learning, which has been also around for decades. And I wonder here if reinforcement learning is logical AI or is it not? And if it is not, why is it not?
So reinforcement learning doesn't really fall in the category of logical AI. Reason is it's again based on experience. So it's based on you explore the environment. So whenever we're talking about agents, reinforcement learning agents, rather than reinforcement learning with human feedback for training large language models. But whenever you're talking about reinforcement learning agents, they explore an environment, they get rewards for that environment, and then they learn how to act in that environment given those rewards. So we don't have an full understanding as to like why decisions have been made at certain points. It's more, this is the policy that a reinforcement learning agent ends up learning. So it's not rule-based. It's not encoded in a way that it's fully interpretable as well.
And one of also the here challenges with agents is just that right now, first, we don't likely have like an official definition of agents, and everyone understands a little bit different what is meant with an agent, plus on top, how we can develop them. There are many ways how can be done, and not only that, but also it is hard for people, especially for enterprise applications, that get reliable results in that, let's say we have a chain of steps, and at some point, one of these steps does not happen. Let's think, okay, the API that this agent was calling is not available. And then all of a sudden, the process breaks, and then it can complete, it fails. If we start using logical systems, robust systems, will we be able to have here more robustness in that, for example, if we're thinking about this idea of an agent that, let's say, has to book a travel of a flight on a travel website, and then all of a sudden, maybe the travel website is not available. If we start embedding logical AI systems or notions, will it become more robust? Will it change, or what will it happen when we start doing that?
Yeah. So we did explore using planners with generative AI and actually solved exactly this kind of problems. It does improve performance over using large language models, even the most robust large language models, with upwards of 30%. So there definitely is a very big space to combine generative AI with planners when it comes to action selection. I feel like leaving action selection to large language models is one of those areas that one really shouldn't be leaving to large language models. One of the things that we were kind of exploring, and I do think that there are some applications for it, but maybe not in enterprise settings, is the ability of the large language model choosing different actions to complete a goal without them being preset. So a lot of people and or like a lot of companies look at agents as almost kind of like pre-built pipelines, which are generative AI enabled. So they are they use some AI into the actions, but they're not they use some AI into the actions, but it's not exactly an autonomous agent. It's just a pipeline really with AI. To have truly autonomous agents, you have to have an agent that would be able to choose its own actions. So let's say you try to search for something and you couldn't find it in the local database. So maybe you want to go and search it online, or you maybe want to ask the user and then you send them an email to ask them about the question. So you might have like a set of actions on your disposal, and then you need to choose in whatever way to accomplish your goal. Now, I do feel like enterprises are probably not ready for that, and there aren't that many useful applications for it because companies are already quite afraid of the non-determinism of large language models. And if you throw into the mix them choosing what to do, not only how to respond to things, then it becomes even more complicated to build a good enterprise use case around it. But I do think in like some more maybe low risk scenarios where you just want something done. So whether it comes to like booking flights or booking a hotel or whatever, and maybe if your favorite hotel was not available, you're happy to go for the second best, then that's a good application where it could work.
You were mentioning now that we can have, for example, many people picture agents as just pipelines. So very constrained set of steps. And while at the same time, we have the other side with these completely autonomous systems that they decide by themselves what can be the next step, what can be the alternative. Where in this spectrum would you position logical AI? Is it closer to a pipeline, or is it closer to just something completely autonomous that is not requiring any type of rules or constraints or restrictions?
So logical AI allows you to build completely autonomous systems in a more robust way. It's not to say that you can't do it with large language models. Large language models could choose their own actions and then they could complete the goals themselves as well. It feels like like logical AI is a much better application in those cases, as it's much more constrained and it's only trying to actually solve the goal of, let's say, finding your hotel. Whereas if it's a large language model, it's still solving the goal of what is the best next word in a sentence. So every AI is goal directed, and by using logical AI, you could direct it towards whatever you're actually focused on solving. So I would say logical AI allows you the same level of, or like a similar level of autonomy, but it's optimizing for the right goal. Yeah.
And something that I also think about, these days we have systems like Perplexity AI. So, and there, for example, the other day I was Googling or using Perplexity for searching, let's say, like laptops under $500. And when you use this deep research capability of Perplexity, you see how it is generating a plan and also iteratively validating this plan. So for example, it says, I'll go first to eBay and look there for results. And then it gets the results from eBay and says, I didn't find it there. So now I have to look for this other option and so on. So it's not, let's say that once the plan is created, then this is set in stone and can change, but rather based on the feedback that it's getting from the internet, it's adjusting what's doing. And you basically, from you were saying, given that this is a generative model, this wouldn't be logical AI. So if it's not that, then what is it, and what will it change once we start adding logical AI?
Yeah, it's a really, really good question. So the way reasoning AI works is you have chain of thought. So you say, I want to do step 1, 2, and 3, and then it's going to go and explore step 1, step 2, step 3 sequentially, and it's going to be backtracking to each of those steps until it explores it all, and then it's going to give you an answer. So if normal large language models would just give you an answer and it's kind of immediate and then it just predicts the words. What reasoning AI does is it predicts the words for the reasoning steps and then it predicts the answer as well. So again, like going back to it being kind of like autoregressive, it's kind of if you've thought about something well, then your answer is more likely to be correct, right? Like, so if you have all the logic before it, then whatever you say next will follow from what you've said before, because that's how they work. Now, the way that they're trained is again by given a lot of examples of how you should think. So they're given a lot of examples of chain of thought, and that's how they learn to, let's say, think, right? But that's still, it still works on the same basis. You're still predicting words, and you think what sounds the smartest. And when you do add two use onto it, then you do have the objectivity of that worked, that didn't work, right? So, but example that I kind of like giving is if you think about solving a linear equation, if you ask a large language model to solve a linear equation, you would again think step by step how to do it, and it might still get it wrong. And the reason why it would get it wrong is because it's not actually performing maths. It's never going to be as good as a calculator. So what the combination of generative AI with logical AI really gives you is that like use of a calculator, but it's obviously not calculator. It's a more generic view of two use. So you have general linear solvers, and then as long as you can translate the problem into a linear solver problem, then you can actually get the correct answer for certain.
Now you were explaining the concepts behind reasoning models, and maybe some from the audience might associate it with, so here, DeepSeek R1 or the O models from ChatGPT, from GPT, OpenAI, and so on. And you were saying that because they're in the end regressive, so autoregressive models, just like any other GPT model, other transformer models, and so on, they will always have this limitation that they have this stochasticity, they'll be very open, the changes, result, you will not have this reliability. So does that mean that for logical AI, such that we have logical AI, we need to come up with completely new models? It will need to be possible that, for example, with reasoning models, what we're doing is we're training models using this kind of thought prompting technique in order to get these steps and planning. Now I was thinking maybe if we have these rules, these rule-based systems, maybe as a prompt, maybe a giant prompt full of rules, etc., we end up having a logical AI system of sorts. But now, based on what you were mentioning, I get the impression that this won't be possible, and we need to come up with a complete different architecture that allows us to have some logic, some rules, some structure. Is that correct?
So there are people who are working on different architectures that would allow for less autoregression or would allow for more logical verification. The types of things that we're looking at, and I've been talking about, don't require any extra training. You could maybe add some extra like small amount of fine tuning just to make sure that those systems work well together. But realistically, we take large language models as they are, and then we add those like this extra level of logic onto them.
Another area where members from the audience might associate or might think, hey, this sounds a little bit familiar, is RPA, so here, robot process automation, for example, UiPath and so on, where we have so many systems. So you were mentioning earlier about comparing in an invoice different elements and associating it maybe with so some positions in a, let's say, like an ERP. And this would be a task and activity that would be quite common for UiPath, right? Like you go to the system, you start clicking and associating here some steps and so on. And once you have the workflow, then you can repeat it for new incoming invoices. Will that be superseded by logical AI? So will we be looking back and say, hey, this was how we used to do it? Or will there still be a place for this type of RPA applications, even in a world with logical AI-based systems?
So I think RPA will continue existing. I think it's one of the biggest applications of generative AI in general. And I think that all of those big players who are looking into, who have been working on automation are obviously adding generative AI onto their applications right now as well. I think that they tend to follow quite binary, either this is fully automated or it's not. And it does go back to I'm not sure that this is how humans will be interacting with generative AI in the future. So I think that like more low risk applications which are allowed, that let's say chatbots might be completely unsupervised, because the whole idea is that you'll be able to answer user queries on the spot, and you would need to have millions of people sitting behind the desk answering those queries, right? So those kind of applications, we'd accept that sometimes things might go wrong, but humans might get something wrong every now and again, so it's not the end of the world. But I think, and then speed is the most important thing, but there are other applications where I think you'd rather check if something might be going slightly wrong, and that's not going to be fully automated. So quite unlike how you define a process and that process will just run all the time, I think you'd create a process and then you'd create certain things that you want always to be true, or things you care about, or things that you might want to be double checking. And every time that those kind of maybe things flag, or every time that you feel like there's uncertainty in the large language models, you might want to be checking that. I feel like the current way in which process automation works is either you check everything or you check nothing. And I think with large language models being integrated in, you'll have to have this like kind of middle ground between them.
You also mentioned that with logical AI, we go having more autonomous systems. And something that people will imagine is that I define my rules, let's like as an input, and then the system will follow these rules. However, if we're having autonomous systems, this means that as new information arrives, as things change, then therefore there might be many situations, many cases where these will no longer follow the rules, that there will be maybe a new case, a corner case, and as a result, either is not within the boundaries of the defined system, or it is maybe not, it is counter what the system was saying. In those cases, what is the expected behavior from a logical AI system? Will it just start a process? Will it maybe like rewrite a rule and come up with a new rule, or something else will happen? What can we picture here in these situations where we're faced with an environment that's constantly changing, the new things are happening, and as a result, the rule is not defined or is maybe not the right one for the scenario that here this agent, the system is facing?
Yeah. I think that we are maybe a couple of years away, and I actually don't think it's a technological problem at all. I think it's just more where we are as a society in adopting that technology. I don't think that the kind of workflows that we're automating with leave to a fully non-deterministic systems to automate. So I think that you'd still have the steps that you'd normally have. So you're not going to be having that autonomy within the process unless you've specifically said you're happy with it. So again, in like lower risk scenarios, you might be happy to have multiple things that an agent could explore. But I think when it comes to automating things end to end in a way which is not predefined, enterprises in particular would likely not be happy in proceeding with it. But what sorry, I'm not sure that answers the question, but like happy to elaborate.
So here's something I was thinking was, as is with all technologies, that there are limitations, there is always some scope or some sweet spot that works very well for specific technology. And here, what I'm thinking, so and now also with the discussion of what happens when new thing arrives in a system, how it adjusts and so on, I was wondering, what are the limitations or the constraints of a logical AI system? I'm sure that it's not, let us say here, this perfect world scenario that will allow us to have some sort of like AGI, but rather it will be very useful for some scenarios, for some use cases, and for others might be likely completely unsuitable. So do you have any sort of pointers or like a framework that the audience can have in order to decide for this use case looking forward, I should be considering logical AI, whereas maybe for these other cases, for these other situations, this might not be the right technology for me?
The combination of both is unlikely to be leading to AGI in the sense that that is, again, very wide intelligence. I think the cases where the combination of both makes sense are the cases where you would either not trust a large language model by itself. So let's say the workflow or the task at hand is too complex, or it's too high value. So you just need that like either extra level of structure and explainability, or you need the extra capabilities that adding a, let's say, heuristic based approach gives you on top of what large language models give you. So anything that you would have normally solved with an algorithm had it been able to understand language, you'd probably solve in a combination of large language models with logic.
And you're talking with many companies and doing a lot of like evangelization for logical AI. So this is not maybe not something that people have on top of their minds, and you come and explain to them, maybe that educate them. What have been some misconceptions or realizations that you notice that people have whenever you start showing them what's possible or what's not possible using logical AI?
I think a lot of the companies we are talking to, we have heard a lot of the same issues arise in the adoption of large language models in those industries and in those kind of use cases. So we have been lucky enough to actually have pretty open mind on the other side as to why the combination of those two techniques makes sense. And I think there is quite a lot of like genuine interest towards what kind of results could be achieved with it. We have been able to like prove in certain scenarios. So we've done some mathematical Olympiad questions where we've outperformed large language models. We've done planning benchmarks where we've outperformed them. We've done a bunch of kind of like, even when it comes down to like extracting information from like financial statements and doing that in a reliable way. You can outperform large language models with RAG by almost like 30% just by adding like extra structure into like the way you look for the information and so on. So there are kind of undeniable benefits in very like narrow fields, and we are still exploring the exact different like actions and different things that are useful in different industries. But I think we've been getting quite a lot of interest in use cases which people are keen to solve and haven't been able to yet.
If someone is listening and say, hey, you convinced me, so here, logical AI sounds what I need for my business is really what I've been missing. How can people get started? Can they somehow do things on their own, or is it something where you have to come and so show them and implement things for them?
Well, difficult to answer. We are basically creating a library of those actions for different industries where the common use cases that we hear we're able to automate, and then obviously go to other companies and offer them the solution. So, if they're interested, please get in touch. I'm here. I would love to have a chat. But yeah, it's definitely something that you can experiment as well internally, but it is quite research heavy. So I think one of the upsides of having someone come in and actually help you solve the problem is that you don't really need to invest in the R&D that you would have to if you were to try to like combine them yourself. It is very cutting edge.
We've covered so many topics, and there is still, for sure, so many more things to discuss. And I was here thinking, hey, are there things that we haven't yet discussed, or anything that you'd like to leave the audience as a message that would be important to know about logical AI, or like the type of activities, the type of problems that you're currently solving?
It's a hard one. I would say that large language models are an incredibly powerful tool, and they open up a lot of applications that software was never able to do. And their limitations are not a reason not to adopt it. It's acknowledging those limitations and working with them in a way that works with humans, not against them, is the way to get the productivity gains that everyone's promising.
And I'm sure that that'll appeal to so many who are exactly that, afraid that now, with all this automation in AI, they might become even irrelevant because all the things that are happening that make things faster, easier, more affordable to execute. And with that, I'm sure that some will say, hey, sounds interesting. However, I do not know how I can get started. You were mentioning now that you are working on a library that you'll be releasing at some point in the future. So how can people get in touch? How can people find out more? Where can they find you?
They could email me, Sophia.Kalanovska at Tromero.ai. You can get in touch on LinkedIn as well. It's just my name. You can get in touch from our website as well. You can book a call. So yeah, many ways to get in touch. Please do.
And I'm sure that many will like to do that, because we just have this deep dive on the topic. And nevertheless, I still feel that, wow, there are so many questions that are left unanswered that I'd like to know. And when I'm thinking, there are so many options, potential, and applications that can be used for the space of logical AI. So with that said, thank you so much, Sophia, for joining us today. And for everyone else, you know now where to find Sophia. If you're curious about logical AI, how you can start using it in your enterprise, in your business, in your problems, then go and reach out to Sophia. Look out for Tromero. And thank you so much for joining here to the session.
Thank you so much, Rod. Yeah, thank you, everyone. Thank you.